What is NoSQL and how it works? NoSQL means not only SQL and is a broad category of database management systems. The main characteristic of NoSQL is that it is non-adherent and more flexible to relational database concepts. NoSQL is utilized by distributed data stores that have large data storage requirements, popular with large companies who process large amounts of data, for example Google. System speed is slowed down when a relational database system is used. NoSQL speeds up systems by spreading the database load on multiple hosts, also known as scaling out. NoSQL works by creating data fields, and each data value would be stored with its unique attributes. The database load is dispensed to multiple hosts. NoSQL does not use SQL to query data. No strict schema is followed, like relationship models do. NoSQL is considered specialized systems. It allows structure to be applied, but it is not required immediately, resulting in data being stored even if there is not currently a logical structure.
The first type of NoSQL we will look at is key value store NoSQL database. The schemaless format is a key value database, like React. It's just about what you need for your storage needs. The key can be synthetic or auto-generated, while the value can be string, JSON, blob, and a few other files. The key value type basically uses hash tables which there is an existing unique key and a pointer in a particular item of data. A bucket is a logical group of keys, but they don't physically group the data. There can be identical keys in different buckets. Performance is enhanced to a great degree because of the cache mechanism that accompanies the mappings. To read the value, you will need to know both the key and the bucket, because the real key is the hash, the bucket plus the key. There is no complexity around the key value store database model, as this can be implemented in a breeze. Not an ideal method if you're only looking just to update any part of value in the query. We try and reflect back on CPA theorem. It just becomes quite clear that the key value stores are great around the availability and partition aspects, but definitely lack consistency.
SQL traditional database. A traditional SQL database is a relational database and is named for the language it is written in, structured query language. An SQL database is more rigid and structured, kind of like a phone book. SQL databases were developed by IBM in the 1970s and are made up of two or more tables, columns, and rows. Each row has attributes and each column has specific types of information such as names and numbers. The relationships between the tables or entities is called a schema. In an SQL database, a schema must be defined before information can be added to the tables or entities. In order for an SQL database to be useful, the data being stored within the database must be carefully organized and stored. In order to prevent data redundancies and sync errors, it is important to emphasize the design of schemas. The more organized and structured an SQL database is, the less flexible it becomes. There are several types of SQL databases. There is MySQL, Oracle, IMDB2, Sybase, MS SQL Server, Microsoft Azure, MariaDB, and PostgreSQL. Structured query language is a programming language used by database architects to design relational database. In an SQL database like MySQL, Sybase, Oracle, or IBM, it executes queries, retrieves data, and edits data by updating, deleting, and creating new records. SQL is a lightweight, declarative language that does a lot of heavy lifting for the relational database, acting like a database's version of a server-side script. One particular advantage of SQL is it is simple yet powerful join clause, which allows developers to retrieve relational data stored across multiple tables with a single command. Another reason SQL databases remain popular is that they fit naturally into many variable software stacks, including LAMP and Ruby-based stacks. These databases are well understood and widely supported, which can be a major advantage if you run into problems.
So one technology of NoSQL is auto-sharding. Because of the way they are structured, relational databases usually scale vertically. A single server has to host an entire database to ensure acceptable performance for cross-table joins and transactions. This gets expensive quickly, places limits on scale, and creates a relatively small number of failure points for database infrastructure. The solution to support rapidly growing applications is to scale horizontally by adding servers instead of concentrating more capacity in a single server. Sharding a database across many server instances can be achieved with SQL databases, but usually is accomplished through SANs and other complex arrangements for making hardware act as a single server. Because the database does not provide this ability natively, development teams take on the work of deploying multiple relational databases across a number of machines. Data is stored in each database instance autonomously. Application code is developed to distribute the data, distribute queries, and aggregate the results of data across all the database instances. Additional code must be developed to handle resource failures, to perform joins across different databases for data rebalancing, replication, and other requirements. Furthermore, many benefits of the relational database, such as transactional integrity, and compromised or eliminated when employing manual sharding. Cloud computing makes this significantly easier, with providers such as Amazon Web Services providing virtually unlimited capacity on demand and taking care of all the necessary infrastructure administration tasks. Developers no longer need to construct complex, expensive platforms to support their applications and can concentrate on writing application code. Commodity servers can provide the same processing and storage capabilities as single high-end server for a fraction of the price.